June 1941. The Royal Small Arms Factory at Enfield. Winston Churchill stands in the testing range, cigar clenched between his teeth, watching a demonstration of Britain's newest submachine gun. The weapon fires. Churchill's expression darkens. He turns to the engineers and delivers his verdict with characteristic bluntness. The gun is crude, ugly, unworthy of British soldiers. He personally rejects it. Cut to 1944. Normandy beaches. British paratroopers storm ashore carrying that same weapon Churchill had condemned. 4 million of them would be manufactured before the war ended. The gun Churchill called too ugly for his soldiers became the weapon that armed them through victory. It had no wooden furniture, no polished bluing, no elegant curves. It looked like something assembled in a garage from plumbing parts. It was, by every aesthetic standard Churchill valued, an insult to British craftsmanship. It was also the fastest, cheapest, most practical submachine gun ever produced, and it armed more British soldiers than any other weapon in history. The Sten gun was never meant to be beautiful. It was meant to be everywhere, and it achieved that goal with ruthless efficiency. What Churchill rejected in 1941 became what Britain depended on by 1942. The problem facing British ordnance planners in June 1940 was simple to state and nearly impossible to solve. The British Expeditionary Force had just been evacuated from Dunkirk, leaving behind virtually every piece of heavy equipment they possessed. The exact numbers remain disputed, but estimates suggest approximately 475 tanks, 38,000 vehicles, 12,000 motorcycles, 8,000 telephones, 90,000 rifles, 7,000 tons of ammunition, 2,300 artillery pieces, and 400 anti-tank guns were abandoned on French beaches. Britain faced the imminent threat of German invasion with an army that had weapons for perhaps 1 soldier in 3. The situation was worse than numbers suggested. Britain needed submachine guns for close-quarters combat, for paratroopers, for commando raids, for resistance groups they were beginning to organize across occupied Europe. The Thompson submachine gun existed, but it was catastrophically expensive. Each Thompson cost approximately £50 sterling and required 150 separate machined parts and extensive skilled labor. Britain could not afford to equip its forces with Thompsons, and it could not manufacture them fast enough, even if cost were no object. The specification was clear. Britain needed a submachine gun that could be produced by semi-skilled workers using basic machinery, that cost a fraction of existing weapons, that used the standard 9mm ammunition already in British stockpiles, and that could be manufactured in quantities measured not in thousands, but in millions. The requirement seemed impossible. The task fell to Major Reginald Shepherd and Harold Turpin, working at the Royal Small Arms Factory in Enfield. They approached the problem not as gunsmiths crafting weapons, but as industrial engineers designing a product for mass manufacture. The name Sten itself came from their initials combined with Enfield. Their philosophy was radical. Every feature that did not directly contribute to the gun firing reliably would be eliminated. Every component would be designed for the simplest possible manufacturing process. Machining would be minimized. Stamping would be maximized. The weapon would be ugly, crude, basic. It would also work. They broke the challenge into 3 parts. First, minimize component count. The Thompson required over 150 precision-machined parts. Shepherd and Turpin reduced the Sten to 47 parts, many of which were simple stampings that could be produced by workers with minimal training. The receiver was a simple steel tube. The barrel shroud was stamped sheet metal. The stock was welded steel tubing. A competent factory worker could stamp out receiver components faster than a master gunsmith could file a single Thompson part. Second, simplify assembly. The Sten used basic welding and pinning rather than complex machining and fitting. The bolt was a simple rectangular mass of metal with the firing pin welded to its face. The return spring was standard hardware store specification. The magazine housing was welded to the receiver at a 90-degree angle, making the weapon instantly recognizable and allowing gravity to assist feeding. Everything about the design prioritized function and manufacturing speed. Third, reduce cost to absolute minimum. They eliminated every expensive process. No bluing, just basic paint or nothing. No wooden stock, just steel tubing. No elaborate sights, just basic posts. No machined parts where stampings would suffice. The final production cost was approximately £2.10, roughly 5% of a Thompson's cost. For the price of one Thompson, Britain could field 20 Stens. The effect was extraordinary. Where a Thompson required approximately 5 hours of skilled machining per weapon, a Sten required less than 5 man-hours total, most of it semi-skilled labor. A small factory with basic metalworking equipment could produce Stens. A bicycle manufacturer could produce Stens. By 1942, dozens of facilities across Britain were stamping out Sten components, and weapons were being assembled faster than they could be distributed. The weapon itself measured 762 millimeters in length, with stock extended, 482 millimeters with stock folded on later models. The barrel was 196 millimeters long. The magazine protruded horizontally from the left side of the receiver, a 32-round box that was the weapon's most distinctive and controversial feature. The sights were minimal, just a simple post front and aperture rear, fixed for 50 meters. The stock on early models was a T-shaped steel tube frame. Later versions featured a simplified stock or a wire frame that folded. There was no safety mechanism on early versions, just a slot cut in the bolt handle that allowed it to be rotated into a notch. The trigger mechanism was so basic it could be disassembled with bare hands. This was not a refined weapon. This was a weapon designed to be produced by a country fighting for survival. The cyclic rate of fire was approximately 550 rounds per minute for the Mk2, the most common variant. The effective range was roughly 50 to 100 meters, though the 9mm parabellum round could reach 200 meters. Accuracy beyond 50 meters was academic. The Sten was designed for the ranges at which most infantry combat occurred, for clearing buildings, for ambushes, for close-quarters raids where a soldier needed sustained automatic fire and the ability to reload quickly. Production began in June 1941. The exact final count remains uncertain even today, but estimates suggest over 4 million units were manufactured between 1941 and 1945, with some sources claiming 4.5 million. The variance reflects the decentralized production. Multiple facilities manufactured components. Many weapons were assembled in small workshops. Record-keeping was informal when production was urgent. What remains certain is that the Sten became the second most produced submachine gun of the entire war, exceeded only by the Soviet PPSH-41. The earliest production models, designated Mk1, featured a wooden foregrip and a flash hider. These were quickly abandoned as unnecessary. The Mk2 eliminated the flash hider and foregrip, becoming the definitive version. Over 2 million Mk2 Stens were manufactured, making it one of the most common variants. The Mk3 simplified manufacturing even further. The Mk produced in 1944, added refinements, including a wooden stock and pistol grip, an attempt to make the weapon slightly more presentable. The Mk6 was a suppressed version for SOE operations, with a barrel shroud wrapped in sound-dampening material. The first operational use came in 1942. British and Commonwealth forces began receiving Stens as primary weapons. Initial reception was mixed. Soldiers accustomed to Lee-Enfield rifles found the Sten crude and temperamental. The horizontal magazine was prone to damage. The weapon would fire from an open bolt, making accidental discharges common if dropped. Early models had a tendency to fire full automatic when the bolt was released, even with the trigger untouched. Soldiers learned quickly. Keep the magazine seated firmly. Keep the weapon pointed in a safe direction. Treat the safety notch with respect. Despite its flaws, the Sten worked, and working was enough. In North Africa, British forces used Stens extensively during the desert campaigns. The weapon's simplicity proved advantageous in sandy conditions where more refined weapons jammed. In Italy, Canadian troops armed with Stens fought through mountains and cities where close-quarters fighting made the submachine gun invaluable. In Northwest Europe following D-Day, the Sten became ubiquitous. Paratroopers carried them, commandos preferred them, tank crews used them. The weapon was light enough to carry as a secondary weapon, yet provided firepower no rifle could match at close range. One documented account from Caen describes a British soldier clearing a German-held building room by room with a Sten. The weapon sustained fire, allowing him to suppress defenders long enough for grenades to be deployed. The Special Operations Executive distributed tens of thousands of Stens to resistance groups across occupied Europe. The weapon's simplicity made it ideal for partisan use. It could be disassembled, hidden, and reassembled by fighters with minimal training. The French resistance called it the reliable friend. Polish partisans used Stens during the Warsaw Uprising, where approximately 1,000 weapons were parachuted into the city. Danish resistance fighters used suppressed Mk6 Stens for sabotage operations. The weapon that Churchill had rejected as too ugly for British soldiers became the weapon that armed Europe's underground armies. The psychological impact on German forces was substantial. Captured Stens were highly prized. German soldiers often discarded their own MP40s in favor of Stens, preferring the British weapon's higher rate of fire and simpler magazine system. The Germans were so impressed they produced their own copy, the MP 3008, in early 1945 when their own production facilities were being destroyed. It was a direct copy of the Sten, produced in German factories using the same stamping techniques. The weapon Germany's leader had mocked became the weapon Germany copied when desperate. If you're finding this deep dive into rejected weapons interesting, a quick subscribe helps more than you know. Now, let us examine how the Sten compared to what other nations were producing. German submachine gun production during this period centered on the MP40, a weapon that represented the opposite philosophy. The MP40 was well machined, featuring a folding stock, a vertical magazine well, and careful manufacturing. It cost approximately 57 Reichsmarks to produce and required substantially more machined components than the Sten. The MP40 was reliable and effective, achieving approximately 500 to 550 rounds per minute, nearly identical to the Sten. However, Germany produced only approximately 1 million MP40s during the entire war, roughly one-quarter the Sten's production numbers. When German factories were bombed and precision machining became impossible, the MP40 production collapsed. The Sten's cruder manufacturing methods would have allowed continued production even under similar circumstances. The Americans produced the M3 grease gun starting in 1942, a weapon that shared the Sten's philosophy of simplified manufacture. The M3 cost approximately $20, used stamped components, and fired the standard 45 ACP round at approximately 450 rounds per minute. It was effective and cheap. However, the 45 caliber limited magazine capacity and increased recoil compared to the 9mm Sten. The M3 also entered production later than the Sten, and its development was influenced by observing British experience with simplified submachine guns. The Sten's design, even in its most basic Mk2 configuration, delivered sustained automatic fire with a 32-round magazine using widely available 9mm ammunition. A comparison of specifications tells the story clearly. The Sten cost £2 10 shillings with 47 parts. The Thompson cost £50 with 150 parts. The MP40 cost 57 Reichsmarks with substantially more machining required. In the category of weapons designed for mass production under wartime conditions, the Sten was in a category of its own. There was one significant limitation. The Sten's open-bolt firing mechanism and basic trigger group made accidental discharges common. Soldiers learned to treat the weapon with constant caution. The horizontal magazine, while allowing gravity-assisted feeding, was vulnerable to damage and could cause the weapon to tip when placed on surfaces. The magazine itself was temperamental, requiring careful loading to prevent jams. These were not trivial flaws. Soldiers died because Stens fired when dropped. Operations failed because magazines jammed at critical moments. Yet these limitations were accepted because the alternative was having no submachine gun at all. The Sten influenced submachine gun development for decades. The Sterling submachine gun, which replaced the Sten in British service in 1953, was essentially a refined Sten with the lessons of wartime use incorporated. The concept of stamped, simplified weapons for mass production became standard doctrine. The Uzi, the Scorpion, countless Cold War submachine guns all descended philosophically from Shepard and Turpin's work. June 1941. The Royal Small Arms Factory at Enfield. British engineers created the weapon their Prime Minister found too ugly to accept. The Sten represents a truth Churchill initially could not see. A weapon measured not in polished steel and walnut stocks, but in production numbers, in cost per unit, in the hands of soldiers who needed firepower immediately. British engineers solved a problem others approached with craftsmanship by abandoning craftsmanship entirely. They turned Britain's industrial capacity into a weapon itself, and they did it with 47 stamped parts, a steel tube, and the willingness to build something ugly that worked. That was British pragmatism. That was industrial warfare. And that was how the weapon Churchill rejected armed 4 million British soldiers through victory.